Okay, so we now know we have an equation we have to work with to figure out our thermal. We have to, figure out what level of thermal we want and then use our depth and our intensity to figure out how many degrees of increase we get per minute and then figure out our treatment time from there. If we just want non-thermal, it gets a little bit easier, okay? So with trying to get non-thermal effects, our whole goal here is the fact that we're just trying to limit the thermal effects. So we want the body to be able to dissipate any heat that is being created from the ultrasound so that the tissue temperature doesn't actually rise, because in most cases that would be contraindicated when we would be using non-thermal. So we'd be in that acute inflammatory stage usually when we're talking about only using non-thermal. So for doing this, we want to always use our temporal average intensity to keep that between zero point 0.2 and zero point 0.3 watts per centimeter squared. So what that is saying is that your total treatment, we only want to be at about a zero point 0.2 to zero point 0.3 watts per centimeter squared, which means that that takes into account both your on and your off time. So this is when we use our duty cycle. So we can get to this zero point 0.2 lots of different ways, okay? Your book really recommends trying to use the smallest duty cycle, so 20 to 25% duty cycle with your settings in order to stay at that zero point 0.2 watts per centimeter, just to really make sure that the heat dissipates. But in theory, you can use a continuous ultrasound and use a setting of zero point 0.2 watts per centimeter squared, and you won't get the thermal effects either. So you get to kind of figure out what you want to do. And essentially, there's no 100% right answer as long as you're keeping your average temporal intensity below 0.2 or 0.3. So examples I have here, you can set a duty cycle at 20% at 1 watts per centimeter squared, right? So 1 times 0.2 is going to equal 0.2. Okay, you can have 50% at 0.4, right? So 0.4, 50%, half of 0.4 is 0.2. So both of those get you to where you want to be of about 0.2. You can even have those lower. So we could have 20% at 0.5, and that would get us below 0.2. We just always want to stay kind of below 0.2 or 0.3. Your frequency is still going to depend on the depth of your tissue. So you're still going to pick 1 megahertz or 3 megahertz, and that shouldn't affect your heating. Though we do know that 3 megahertz is going to heat faster, so that would be probably even more important to try to do that really low duty cycle. So maybe more of the 20-25% versus trying to do 100% at 0.2 to get to where you want to be. And then your treatment time, because we don't have a chart, we're not trying to be tissue and tissue temperature dependent. Really, our treatment time tends to be somewhere between 5 to 10 minutes. I always recommend longer. I think closer to an 8 to 10 minute treatment. Just because if we really are trying to do that cavitation and that microstreaming, the longer we can have that going, the more likely we'll get some of those analgesic effects, more likely we are to change the cell membrane permeability and to have more effect on that. So just to kind of review, you choose your frequency based on the depth of the tissue, so 1 megahertz or 3 megahertz. You decide your intensity, again, should be set on the BNR. Now it's less important because we're shutting it off with the duty cycle, so the BNR is going to be less of an issue, but it's still something to kind of keep in mind. And then we choose our pulse duty cycle based on the intensity chosen in order to keep that temporal averaged intensity 0.1, 0.2, 0.3, somewhere in there. And then we set our time depending on our goals. So again, I usually recommend somewhere between 8 and 10 minutes. Some places go as low as 5. I just don't think you really get what you want out of 5. But research is kind of mixed on that. So let's go with an Achilles tendon strain, right? Something that's acute, just happened. We want to kind of target the Achilles tendon, which is rich in collagen. So we know ultrasound will be great for that. We want to kind of stimulate that into the healing mode, but we don't want to produce any heat. So we have a 3 megahertz depth because it's pretty superficial. We have a BNR of a 5 to 1 on our machine. So ideally, we maybe want to stay under 1.5 for our watts per centimeter squared intensity. So we decide to go with 1.0. If we're going to use 1.0, then we need to set our duty cycle at 20% in order to get 20% of 1 is 0.2. And so then we always end up staying at 0.2 watts per centimeter squared for the average for our treatment.